In this alternating current, we are
Yes,
having the
sir.
subtopics. Firstly, it is definition of AC, that is alternating current. Okay. And then
Yes, sir.
types of AC, and then
Yes, sir.
difference between AC and DC. DC stands for direct current, whereas AC stands
Yes,
for
sir.
alternating current. Okay. And
Okay,
then,
sir.
we are having the calculation of average value, comma, RMS value of current and voltage.
Yes, sir.
Current and
Yes, sir.
voltage. Next, here we are having the firstly definition of phase. I think in the chapter wave motion or in the wave optics, you might study about the wave phase
Yes,
or
sir.
phase difference. Okay, that one, the definition of phase, and then we are having the phasor diagram. Okay, next
Yes,
we are
sir.
having the AC through. Okay, pure
Yes, sir.
resistor, and then inductor, and then number 3 capacitor. Okay.
Yes, sir.
Okay, fine. And then next, AC through pure inductor, resistor, capacitor, and then AC through LCR in series. And then
Yes, sir.
we are having the power factor, and then power dissipation. Okay, power dissipation.
Yes, sir.
Okay, and then finally we are having the Q factor, bandwidth, and then wattless current. Okay, wattless current. Transformer, did you study it in EMI? Have you studied
Yes, sir. Yes, sir. In GB material is there, sir.
there now? That's why.
Yes, sir.
In some textbooks they will give in EMI. In some textbooks they will give in alternating current. Okay.
Sir, yes, sir. So 1 minute, sir. I'll check whether it's there in this lesson also, sir.
Yeah.
Yes, sir. So, yes, sir. Energy losses in a transformer, that is all there, sir.
So, transformer.
Yes, sir.
Okay, fine. Now see, from this
Yes,
AC alternating
Yes, sir.
current, in the need, they can ask minimum 1 question and maximum 2 questions.
Okay, sir.
Maximum 2 questions. From this,
Yes, sir.
previously they asked on this one, on the transformer. Nowadays they
Okay,
are
sir.
asking on these 2 topics: quality factor, bandwidth, and wattless current, and LCR in series. Okay.
Yes, sir. Yes, sir.
Previously, before 1990s, they asked on this
Yes.
average value.
Oh, okay, sir.
Okay, or on this they
Yes,
asked.
sir.
Okay, give the priority to second priority to this. First priority, it is the last topics.
Okay, sir.
Okay, fine.
Okay, sir.
Firstly, we'll go to the chapter. Now, before going to see the alternating current, Okay. Suppose if I'm having a conductor, okay, let us consider
Yes,
a
sir.
conductor, or I can consider as a resistor, right? Having a resistance
Yes, sir.
R, whenever it is
Yes, sir.
connected to a battery, then what will happen? Okay, from the battery,
Yes, sir.
we are applying a potential V. Okay, as soon as the battery is applied, current will flow through the resistor.
Okay, sir.
So as long as the battery is applied, current will flow through the resistor. So I can say
Yes,
that
sir.
current flowing in the conductor is equal to V by R. Okay, na?
Yes, sir.
So that means with the DC battery, okay, it will flow the charges continuously from the DC
Yes, sir.
battery. It is flow charges continuously.
Yes, sir.
Now here, what I want it is that, suppose let us consider I'm having a different type of conductor. Okay. Suppose let us consider mobile. Whenever I'm charging the mobile, then what happens it is, after some time, I want the mobile. Okay. I want the mobile. Whenever it is 100% charged, it should automatically switch off.
Yes, sir.
Okay. Whenever it is 100% charged, okay, it should be automatically switch off. Supply should be switch off.
Yes, sir.
Okay. For this, people found an, okay, different type of
Yes, sir.
source. Different type of source. Apart from the DC source or DC battery,
Yes, sir.
they found the different type of source, and it can be called as alternating current. It means that, okay, up to a particular
Yes, sir.
point of time, the current will flows. Suppose let us consider 0 to 5 seconds. Current
Yes,
will
sir.
flow. And from 5 seconds to 10 seconds, current will
Yes,
not
sir.
flow. And again, after 5 seconds, that is 10 seconds to 15 seconds, again current will flow.
Yes, sir.
Okay.
Okay, sir.
Again. So we can say here, you can see that 0 to 5 seconds. For every 5 seconds, current is changing.
Yes,
Right?
sir.
So I can say that current is changing periodically with respect to the time.
Yes, sir.
Right? So alternating
Yes, sir.
current is the source in which current or voltage changes periodically with respect
Yes,
to
sir.
time. Can be called as
Yes, sir.
alternating source. Suppose for
Okay,
this
sir.
one only, for this one, I can say that let us consider on x-axis, it is the time.
Yes, sir.
On x-axis, it is the time. And on y-axis, it is the current. Okay.
Yes, sir.
5, 10, 15, 20, and then 25 in seconds. Everywhere it is in seconds only. Okay, na? Fine.
Yes, sir.
Now 0 to 5 seconds, current is flowing through the conductor and it is having 2 ampere. So we'll have like this. From 5 seconds to 10 seconds, there is no current. So it will lies on x-axis. Can I draw?
Yes,
Okay,
sir.
na? Again,
Yes, sir.
10 seconds to 15 seconds. Okay, current will flow. That is 2 ampere.
Yes, sir.
Again, from 15 seconds to 20 seconds, no current will flow. Again, from 20
Yes, sir.
seconds to 25 seconds, current is flowing. So
Yes, sir.
the source which will have the flow of the charge carriers, which changes periodically with respect to time,
Yes, sir.
can be called as alternating current. Whereas direct current
Yes.
means, okay, it
Yes,
will
sir.
flow continuously. It will flow continuously. Alternating current means for an interval of time, okay, current will changes periodically with respect to the time. With respect to the time can be called as alternating current. Okay,
Yes, sir.
fine. Okay. Okay, na? Is it
Yes,
fine?
sir.
Write on the definition.
Yes, sir. Tell me, sir.
Definition of alternating current. If the
Yes, sir.
current flowing through a conductor
Yes,
flowing
sir.
through a conductor changes periodically
Yes, sir.
with respect to time. With respect to time,
Yes, sir.
it can be called as
Yes, sir.
alternating source.
Yes, sir.
Example, draw this
Yes,
diagram.
sir.
Draw this diagram and
Yes, sir. 1 minute, sir.
write down 0 to 5 seconds. Current flowing is 2 ampere. 5 seconds to 10 seconds. Current flowing is 0 ampere. Again, 10 seconds to 15 seconds. Current flowing is equal to 2 ampere. 15 seconds to 20 seconds. Current flowing is 0 ampere. Again, 20 seconds to 25 seconds. Current flowing is 2 ampere. Okay, na?
Yes, sir.
Draw the diagram and write on this data also.
Yes, sir. I'm writing down the data, sir.
This data.
Yes, sir. Completed, sir.
Completed. Now,
Yes, sir.
now, basic form of alternating current. That means, see, I think in previous chapter, you might studied about AC generator.
Yes, sir.
In AC generator, we know that, okay, induced EMF equal to, okay, minus d
Yes,
phi by
sir.
dt. That is, induced EMF opposes the rate of change of magnetic flux, right?
Yes, sir. Yes,
Since
sir.
by definition of magnetic flux, I can write as B bar dot A bar. That is
Yes, sir.
nothing but BA cos theta, where B is the magnetic field and A is the area of the coil, right?
Yes, sir.
Suppose let us consider I'm having a particle, okay, which
Yes,
is
sir.
moving in a circular path. Let us consider I'm having a particle at A.
Yes, sir.
With respect to the center of the path, I will consider the coordinates. This is x-axis, here it is y-axis. Okay.
Yes, sir.
Initially, particle is at point A. At A.
Yes, sir.
It is having a radius as r.
Yes, sir.
Now, by applying a force, the particle moved to the point P, such that it is moving with an angular velocity.
Yes, sir.
That means the particle is having an angular displacement, theta.
Yes, sir.
Particle is moved from A to B. That means A
Yes,
is
sir.
my initial position, B is my final position.
Yes,
When
sir.
the particle is at A, initial angular displacement will be 0. Can I say?
Yes, sir. Yes, sir.
And initial time is 0.
Yes, sir.
At B, angular displacement is theta.
Yes, sir.
And time it is t. So I can write by definition omega equal to d theta by dt. That is
Yes, sir.
omega equal to final angular displacement minus initial angular displacement by final time minus initial time. Can I write?
Yes, sir. Yes, sir.
So omega equal to theta by t.
Yes, sir.
Okay, na?
Yes, sir.
Theta equal to, I can write as omega t.
Yes, sir.
Okay, na? Is it fine?
Yes, sir.
So d phi by dt I am finding. That is d by dt of BA cos omega t. Magnetic field
Yes,
and
sir.
area will be constant with respect to time.
Yes, sir.
So upon differentiation, we'll get as minus BA d by dx of cos x. What is the value? D by
So sin
dx
x.
minus sin x.
Minus sin x, yes, sir.
Instead of t, we are having the omega t. So
Yes,
d by
sir.
dt of omega t. That is minus BA omega sin omega t. So
Yes, sir.
induced EMF is minus d phi by dt. So I can write
Yes,
as
sir.
BA omega sin omega t.
Yes, sir.
If number of turns is 1. If we are having n number of turns, that is
NBA.
NBA omega sin omega t.
Yes, sir.
When omega t equal to 90, we can write it as E equal to
Yes, sir.
NBA omega sin 90.
Yes, sir.
That is, this is the maximum value.
Yes, sir.
So maximum value, we are writing it as NBA omega. That I am writing as E naught. Okay.
Yes, sir.
So induced EMF will be E equal to E naught sin omega t.
Yes, sir.
Similarly, induced EMF I got in the form of E naught sin omega t. Similarly, I
Yes,
can
sir.
write it as alternating voltage. Voltage and induced EMF are opposite to each other.
Yes, sir.
So V equal to V naught sin omega t.
Yes, sir.
So that is the alternating voltage in AC. Okay. This alternating
Yes,
source,
sir.
the basic it is from AC generator. I think in
Yes,
10th
sir.
class also you have studied.
Yes, sir.
Okay. Alternating
Yes, sir.
source voltage is V equal to V naught sin omega t. Okay, na?
Yes,
Keep the
sir.
keep the side heading basic form of AC. Write down this one.
So, yes, sir. I wrote it now, sir.
Okay, na?
Yes, sir.
This page completed total.
Yes, sir. I wrote, sir. Next page only I didn't write it, sir.
Write down. Okay, na? Completed?
Yes, sir. Yes, sir.
Okay, fine. Next one, it is types of alternating source or alternating current.
Yes, sir.
Okay,
Yes, sir.
types of alternating current. Firstly, we are having an sinusoidal AC.
Yes,
Okay,
sir.
that means we are having the either voltage or current will be in the form of sine curve. Will be in the form of sine curve. Okay.
Okay, sir.
Here we got the equation as V equal to V naught sine omega t. Right?
Yes, sir.
Suppose if I consider on x-axis it is omega t, and on
Yes, sir.
y-axis it is alternating voltage. Then we are having the graph. Okay,
Yes, sir.
this one. Is it fine? Now
Yes, sir. Fine, sir.
you can see I am shading the part. Let us consider it is O. This point is B. Okay. This point is C.
Yes.
Okay. So I can say in OB, okay, voltage is along positive y-axis.
Yes, sir.
So OB can be called as O to B, positive half cycle.
Yes, sir. Yes, sir.
Okay. Similarly, BC is having voltage. It is along negative axis
Yes,
or
sir.
negative values. So it can be called as negative half cycle. Okay.
Yes,
So
sir.
from O to C, it is one time period, one cycle.
Yes, sir.
Okay. Time period T.
Yes, sir.
So O to B, I can write as T by 2.
Yes, sir.
B to C is also T by 2.
T by 2. Yes, sir.
Okay. Na? So
Yes, sir.
OC, I can write as OB plus OC.
Yes, sir.
Okay. Now let us consider the points M and another point, this point as N.
Okay,
You can
sir.
see the O to M. Okay. How much it is increased? M to B, that much it is decreased.
Decreased. Yes, sir.
Similarly, B to N, how much it is decreased? From N to C, that much it is increased.
Yes, sir.
Suppose let us consider time taken from O to B is T by 2. What will
Okay,
be
sir.
time taken from O to M?
So T by 4.
T by 4, right now.
Yes, sir.
T by 4. Okay. So now we are finding the value of voltage. Okay.
Yes, sir.
When time equal to T by 4.
Yes, sir.
Okay. For that,
Yes,
I
sir.
know that angular frequency omega equal to 2 pi n,
Yes, sir.
which is nothing but 2 pi by T.
Yes, sir.
Frequency equal to reciprocal of time period.
Time period. Yes, sir.
Okay, na?
Yes, sir.
Okay. So V is equal to V naught sine omega T.
Yes,
Suppose
sir.
when T is equal to T by 4, V equal to V naught times sine omega T by 4.
T by 4. Yes, sir.
Okay. I can write as omega into T means 2 pi.
Yes, sir.
And V equal to V naught sine pi by 2. Right? Okay, na? Sine pi by 2. Here, 2 times now. Sine 90. What is the value?
1, sir.
So,
One.
Vmax at t by 4, it is the maximum value.
Yes, sir.
Okay. When small
Yes,
t equal to t by 2, V equal to V naught sine omega into t by 2.
Yes, sir.
So omega into t means I can write as 2 pi.
2 pi by 2. Yes, sir.
That is sine 180.
Yes, sir.
What
Minus
is
1.
No, wrong. Okay, fine.
Yes, sir.
See, sine pi, that is sine 180. I can write as
Yes.
sine of 180 minus 0. 180
Yes, sir.
minus theta lies in which quadrant? 180 minus theta
Sir.
lies.
Second quadrant.
Very good. Second quadrant. In second quadrant, sign is positive or negative?
So positive, positive.
Plus 180 minus theta, trigonometry ratio will change or will not change?
Sir, sorry, sir.
Will not change. Sin 0 is 0.
0, yes, sir.
Okay. So
Okay, sir.
V will be equal to 0. You can see in the graph.
Yes, sir.
At t by 2 here now.
Yes, sir. Yes, sir.
Okay. Like that we need to find for every value. 3t by 4, 2t, like that.
Yes, sir.
Okay.
Yes, sir.
Fine. First form it is sinusoidal form. Okay.
Yes, sir.
This one completed.
Yes, sir. Completed, sir.
This page.
So, yes, sir. Wrote, sir.
Okay. Next, second one, it is square form of AC. Because entire in alternating current, we are using the
Yes, sir.
sinusoidal form.
Yes, sir.
Okay.
Yes, sir.
Suppose let us consider on x-axis it is the time. Okay. And on y-axis it is voltage. Suppose same as like before, I will consider
Yes, sir.
15, 20, and then 25. 0 to 5 seconds, we are having a voltage. Let us consider it as plus 2 volt.
Yes, sir.
And from 5 seconds to 10 seconds, it is having an minus 2 volt. Need not
Yes, sir.
necessarily every time it must be 0. It can be periodically changes. It can have any
Okay,
value.
sir.
It can
Okay,
have
sir.
any value. But see, in the period of 0 to 5 seconds,
Yes, sir.
whatever the voltage we got, same voltage
Yes,
should
sir.
obtain in the next period also.
Okay, sir.
Okay, na?
Okay,
So
sir.
0 to 5 seconds, we are having an voltage is plus 2 volt. And 5 seconds to 10 seconds, we are having a voltage minus 2. So this plus 2 volt and minus 2 volt is periodically changing. Okay.
Yes, sir.
Periodically changing. Fine. This type of waveform can be called as square waveform. This type
Okay,
of
sir.
waveform. And then next one, this square waveform mostly will use in the treatment. Okay, either in the cancer or heart attack to see the pulse.
Okay, sir.
To see the pulse.
Okay,
We
sir.
are having a device called CRT, cathode ray tube.
Yes.
On that
Yes, sir.
pulse, on that They will give the heart pulse.
Yes, sir. Yes, sir.
Okay. Mostly that
Yes.
heart pulse they will express in the form of square wave form.
Okay, sir.
Okay.
Okay, sir.
For the treatment, okay, for the treatment,
Yes.
we'll use the
Yes, sir.
square wave form. Okay. In the
Okay, sir.
security signals like army or navy people, okay, in order to
Yes,
know
sir.
any stranger is coming or not, they will use the sinusoidal pulse.
Yes, sir.
They will use the sinusoidal pulse. Okay. Okay. Next, triangular form of AC. Triangular form of AC. AC means
Alternating.
Alternating current.
Alternating.
Hmm.
Yes, sir.
So here you can see the before one. In the square waveform, if you observe carefully, it is in the
Yes,
form
sir.
of a square. See, waveform
Yes,
it is
sir.
in the form of a square. The both positive half cycle and negative half cycle, it is in the form of square. That's why it can be called square waveform.
Yes, sir.
Similarly, we are having the on x-axis, we are having the time, and on y-axis, we are having the voltage. Here, up to a particular time, 0, and then 5, and then 10. We are having the pulses which is in the shape of triangle. 0
Yes,
to
sir.
5 seconds. We are having a voltage, suppose plus 3 volt. Okay. 5 seconds to 10 seconds. We are having a voltage
Yes, sir.
as 0. Next, 10 seconds to 15 seconds. Again, voltage is plus 3 volt.
Yes, sir.
This type of waveform can be called triangular waveform. Okay,
Okay, sir.
fine.
Yes, sir.
Completed. Firstly,
Yes, sir. Completed, sir.
this page completed.
Yes, sir.
This page.
Yes, sir.
Okay, fine. Next one, it is calculation of average value and mean value.
Yes,
RMS
sir.
value. Now you can see, suppose if we are having an sinusoidal waveform of AC like this. On x-axis it is time and on y-axis it is
Yes.
voltage. Okay.
Yes, sir.
Okay. Now let us consider the points. This point as M, B, C, D, E, and then F. Okay, na? Fine. Okay.
Yes, sir.
Now we can see at which points voltage will be maximum.
Yes, sir.
At which points voltage will be maximum?
Sir, M and E, sir.
At M comma E, right? At
E,
M
yes,
comma
sir.
E,
Yes, sir.
voltage is maximum.
Maximum, yes, sir.
At C is also maximum, but it is in the opposite in
Negative.
direction. Negative value.
Yes.
Okay.
Yes, sir.
Here this
Yes,
one
sir.
we can call it's a minus V naught, and this is plus V naught.
Yes,
Okay.
sir. Yes, sir.
So whenever the voltage is maximum, we can call it as peak voltage or voltage amplitude. Voltage
Yes, sir.
amplitude. Okay. This is the maximum.
Yes, sir.
This is my V
Yes,
naught.
sir.
Okay. Peak voltage or voltage amplitude, or we can also call it as instantaneous voltage.
Yes, sir.
Okay, fine. Peak voltage or voltage amplitude or instantaneous voltage. Okay, na?
Yes, sir.
Fine. Okay. So this peak voltage or instantaneous voltage or voltage amplitude will be indicated with V naught.
Yes, sir.
Similarly, suppose if I'm having an graph between current versus time. Suppose
Yes,
this
sir.
is the current. Okay.
Yes, sir.
Now we are having the graph as sinusoidal graph. Okay. Suppose
Yes,
same
sir.
as like before. Here it is M, B, C, D, E, F. I can say that at M and E, we are having the current is maximum.
Yes, sir.
So this can be called as peak current or
Yes, sir.
current amplitude or instantaneous current. Can I write?
Yes, sir.
Okay, na? Even at the bottom in the negative half cycle, it is
Yes, sir.
minus I naught. Here it is plus I naught. Okay, na?
Yes,
Where
sir.
peak current will indicate with either with capital letter I or small letter I. No problem.
Yes,
Okay,
sir.
na? Fine. Completed.
Yes, sir.
Okay, fine. Next one, we need to find the, okay, what is the average value of current and voltage in a half cycle and
Yes,
in a
sir.
complete cycle. We can see, okay, O to B, I can call it as an half cycle. Okay, O to D, I can call as a complete cycle. Okay, is it fine? Hello. O to B, I can call it as